Hey, how y'all doing today? Happy Friday to you who are getting this on Friday, and welcome to Monday for those of you who are seeing this on Monday. Either way, you're at home enjoying this. Maybe you got a cup of coffee next to you, maybe you got a bagel. Who knows? But either way, you're living the good life. So, what we're going to talk about today is calculating velocity. We've been kind of dancing around the topic a little bit. We've talked about a couple other ideas, but we're going to start getting into the nitty-gritty and start actually calculating it today. So make sure you have your notes on standby. We're going to be running through quite a bit. You're going to have to take a few notes. You can go back and screen this a couple times or stop the video whenever you need to just to make sure you have it, but try not to miss anything as we go along. Feel free to stop as needed. So our starting point is we've been talking about distance and displacement, and they don't really mean the same thing. For instance, if you have something that travels 7 centimeters east and then all of a sudden travels 2 centimeters back west, their displacement and distance are not going to be the same. Their distance would have been 7 centimeters because they walked there and back, but your displacement would only be a total of 5 centimeters. So a big difference there. In this case, the distance would equal 9 centimeters, whereas the displacement equals a mere 5 centimeters. So kind of a difference between distance and displacement. Now another thing that's true about displacement is that it includes a direction. So this ended up being 5 centimeters, and the directions that I used said that it was east. So I'm going to include that as part of my deal. So distance and displacement, quick review. So if I were to go on this journey, okay, and I travel, let's say that I travel 3 meters up this way, and I travel 4 meters this way, my displacement and my distance again are going to be different things. My displacement is going to be here because I'm there from where I started. My distance would be 7 meters, but this is a 3, 4, 5 triangle, so my displacement would actually be 5 meters. 7 meters of distance, 3 plus 4, 5 meters of displacement, and this would be right and up. I would need a direction, whatever direction that would be. So you'd need to include that. So that is what displacement has that velocity doesn't. So now we're going to contrast this with velocity and speed, and remember, if you look at it, velocity is displacement divided by time, where speed is distance divided by time. Now, in most circumstances in this class, guys, we will be able to use these interchangeably. In fact, the equation we use is going to be kind of interchangeable. But the thing that this is going to have, again, if I have a velocity, it will normally include a direction, such as 40 miles per hour to the west. Okay, so just kind of bear that in mind as we go through these problems. So, with velocity, and we've hinted at this with some of our graphing, and again, we're going to incorporate speed equals distance divided by time. I'm going to cheat here, and I'm going to say that velocity is, even though you know better, I don't know very much, I'm going to say that velocity equals distance divided by time. And it's just going to work easier for some of the things that we're going to be doing here. So if that's the case, my velocity or my speed doesn't always have to be the case. So let's say I take 1 hour to drive to Minneapolis, and that's 50 miles away. I drove 50 miles in 1 hour. My average speed is 50 miles per hour because that's a distance divided by a time. Now, again, I'm cheating, calling that velocity for now, and you'll see why in a second. But during the trip, sometimes I have to go through downtown Red Wing, and I might travel at 30 miles an hour. Sometimes I'm at a stoplight where I'm at 0 miles an hour, but then when I get on the highway, I might be traveling 70 miles an hour. So even though this might be my average speed, this slope here, there might be times in my journey where I might be traveling slower than this, or I might be stopped, okay, where I might be going faster than this. Okay, so there's all sorts of things in this journey. This would be the average. Each of these would be the instantaneous. The slope here would be the distance divided by time. Distance divided by time, you know what that gives me? That gives me my speed or my velocity. So during this journey here, my velocity would sometimes be low, and then I would have no velocity, and then all of a sudden it would be high. Oops, that's not good. X that out. Okay, but either way, I'm describing my journey along the way with what is happening. Okay, so these two graphs kind of describe the same type of motion, but I need to kind of connect these points here. So you should start getting a little bit more familiar with these graphs as time goes by, and we're going to be employing them in the lab as well. Okay, the slope of a distance versus time graph is the speed. If I take the slope of this red line, that is the speed, because distance divided by time is going to be my speed. So how do we solve these types of problems? Well, if this is my initial equation, I'm going to shorthand this just into the variables. I'm going to say that V equals d divided by t. Velocity equals displacement divided by time. Or, again, I'm cheating a little bit. I'm using these interchangeably, but you're going to see why. Now, in math class, we might say that 3 equals 6 divided by 2. So go with me here as I'm thinking this out. If that's the case, I can just easily say that 6 equals 3 times 2. I'm multiplying this 2 times this 3, and I get 6. So if that's the case, I can just as easily say that distance equals velocity times time. There's no difference between what I did with this equation and what I did with this equation. I can also say that 2 equals 6 divided by 3. I'm just taking this 2, putting it in the denominator. Here I'm taking this v and putting it in the denominator. So here you'll notice that if I know this equation, velocity equals distance divided by time, I get 3 equations for the price of 1. Now, if you don't want to memorize these 3 equations, there's something that I've got, a little trick that can help you out. Okay? I want you to, I would all call these equations part of my toolbox. Anytime I need an equation, I'm just going to go into my toolbox, grab one of these equations. But I've got a little trick for you to help you figure out which equation to use. And I'd ask that you draw this triangle in your notes along with everything else you've written so far. So let's say I've got a problem where they give you the distance and the time, and you want to know the velocity, but you forgot the equation. If you have this triangle for you, and you've got this figured out, just go like this, say velocity. Oh, I forgot what that is. Then you just kind of say, oh, that's distance divided by time. Okay, pretty easy. Let's say you want distance. Okay, I'm looking for distance. I don't know what it is. Well, that's velocity times time. Or maybe you want time. You're looking for time, you don't know what it is. Well, that's distance going to be divided by velocity. So whatever you are looking for, this would be divided by that, this would be divided by that, this times that. So if you use this triangle, it's a little trick to kind of help you out and remember which equation you need to use. So I'm going to stop this video now, and I'm going to create a second one to walk you through 3 problems. Okay, I just want to make sure I have enough time.